19 hours and 45 minutes. That is how long it takes for a signal from Voyager 2 to cross the darkness and reach Earth. Not minutes, not seconds, but almost an entire day. A faint radio whisper, traveling for more than 13 billion miles away, sent by a spacecraft launched in 1977, powered by fading plutonium, running on less electricity than a refrigerator light bulb, and still trying to tell us what it found beyond the edge of the sun's protection. And what Voyager 2 has been sending back is not just data. It is a warning. Not the kind of warning people imagine. Not an asteroid. Not an alien signal. Not a message carved into space. Something quieter. Something more scientific. Something more disturbing. Voyager 2 crossed the boundary of our solar system and discovered that the edge was not smooth, calm, or empty. It was hotter than expected, denser than expected, and more turbulent than expected. The invisible wall between the sun's domain and interstellar space was not what our models predicted. And now, as Voyager 2 slowly runs out of power, every transmission could be one of its last. A dying spacecraft is still teaching us that the space beyond our solar system is far stranger than we believed. And the most unsettling part is this: we may only understand the warning after the voice that sent it has gone silent forever. Voyager 2 launched from Cape Canaveral on August 20, 1977. Its mission was bold but limited. Fly past the outer planets using a rare gravitational alignment that happens only about once every 175 years. Visit Jupiter. Visit Saturn. Then, if everything went perfectly, continue toward Uranus and Neptune. NASA had one chance to use that planetary alignment, and Voyager 2 became the spacecraft that took the long road through the outer solar system. It flew past Jupiter in 1979 and helped reveal a system more violent and active than anyone expected. It passed Saturn in 1981, studying the rings and moons of that enormous world. Then it did something no other spacecraft has ever done. It visited Uranus. In 1986, Voyager 2 became the only machine in human history to fly past the seventh planet up close. It discovered new moons, studied its strangely tilted magnetic field, and recorded radiation data that would confuse scientists for decades. Then, in 1989, it reached Neptune. It revealed a colossal dark storm in Neptune's atmosphere, discovered new moons, studied its rings, and exposed geysers erupting from Triton, a frozen moon that suddenly looked far more alive than expected. That should have been the end. The mission had already achieved more than anyone had dared to hope. But Voyager 2 kept going, past Neptune, past the planets, and past the familiar architecture of the solar system. Its cameras were eventually switched off. Its instruments were managed carefully. Its power source began to fade. The world it left behind changed completely. But the spacecraft continued traveling outward, still communicating with Earth across a distance so vast that every command takes nearly a day to arrive, and every reply takes nearly another day to return. This is not a normal spacecraft anymore. It is a survivor, a machine from the 1970s operating in a region where no engineer can touch it. No repair is possible, and one tiny mistake can mean silence. And yet, somehow, it is still transmitting. The warning began when Voyager 2 reached the heliopause, the invisible boundary where the solar wind ends, the place where the sun's protective bubble gives way to the galaxy. Most people imagine the edge of the solar system as a distant line, a quiet boundary where the planets end and empty space begins. But Voyager 2 showed us that this picture is wrong. The real boundary is called the heliopause. It is the outer edge of the heliosphere, the vast bubble created by the solar wind, a stream of charged particles flowing outward from the sun in every direction. Inside the heliosphere, the sun still dominates. Its magnetic field stretches outward. Its particles shape the environment. Its influence protects the planets from part of the harsher galactic radiation beyond. But far beyond Neptune, the solar wind weakens. Eventually, it presses against the interstellar medium, the gas, dust, plasma, magnetic fields, and radiation between the stars. That contact region is the heliopause. For decades, scientists built models of what this boundary should be like. Many expected a transition that was gradual, complex, but understandable, a soft outer edge where solar material slowly gave way to interstellar space. Then Voyager 2 crossed it on November 5, 2018, and the data did not behave gently. The spacecraft's instruments detected a sharp jump in plasma density. Not a slow fade. Not a smooth transition. A sudden shift, as if Voyager 2 had passed through an invisible wall. The boundary was hotter, denser, and more turbulent than expected. Plasma temperatures near the heliopause were measured in the tens of thousands of Kelvin, a staggering result for a region most people casually imagine as empty and frozen. That does not mean the edge of the solar system is like a furnace. The particles are still incredibly sparse. But the fact that they carried this much energy, and that the boundary behaved so sharply, told scientists something important. Our picture of the edge was incomplete. The solar system does not end softly. It presses against the galaxy, and the galaxy presses back. Voyager 2's transmission was a warning in the language of physics. The boundary between our home and interstellar space is more violent than we thought. That matters because any future mission leaving the solar system will have to cross this same region. A probe, a solar sail, a deep space arc, or one day perhaps even a crewed interstellar mission would not simply glide into peaceful emptiness.